Good morning, sir. I am Devinil. I am from CSEF section. Today I am going to a presentation on potentiometric and amperometric sensors. Understanding the two main types of electrochemical sensors. First of all, what are electrochemical sensors? The electrochemical sensors that are devices that detect chemicals using electrical signals. They change chemical information into a measurable electrical signal. It commonly used in environment, medical and industrial applications. Work based on reactions that happen at the surface of electrodes. For example, a glucose meter used by diabetic patients. It measures the sugar level in blood using an electrochemical sensor. First one is potentiometric sensors. It measures the voltage or potential difference between two electrodes without current flow. This potential difference depends on the ion concentration in the solution. Next work is working principle. One electrode reacts with ions in the solution. A voltage is produced depending on the ion concentration. The voltage value shows how much of that ion is present. For example, pH meter ion selective electrodes. When both electrodes are placed in a solution, a voltage develops that changes according to the ion concentration. Next one is diagram of the potentiometric sensors. The labels to show indicated electrode, reference electrodes or measured voltage. It is amperometric sensors. Amperometric sensor, it measures current produced when a constant voltage is applied between electrodes. Working principle, the analytic undergoes oxidation or reduction at the electrode surface. The current generated is proportional to the analytic concentration. A fixed voltage is applied between the electrodes. When the target substance reacts at the electrode, it produces a current. The current is directly proportional to the concentration of the substance. Example, glucose sensor used by the diabetic patients is a great example. It produces the current produced by the reaction between glucose and oxygen, helping to find glucose levels in blood. It is dissolved oxygen sensor. The diagram of the amperometric sensor labels to show working electrode, counter electrode, flow of current. The difference between potentiometric and amperometric sensors. Potentiometric sensor, amperometric sensor. It measures potential difference between two electrodes without drawing current. In amperometric sensor, it measures current that flow due to a redox reaction at the electrode. It measures quantity is voltage, it measured quantity is current. In potentiometric sensors, it depends on ion concentration in solution. In amperometric sensor, depend on rate of chemical reaction. In potentiometric sensor, no current flow, only potential difference is measured. In amperometric sensor, current flow is measured due under a fixed potential. In potentiometric sensor, good for detecting ionic species. In amperometric sensors, good for detecting electroactive substance. Next one is applications of the potentiometric and amperometric sensors. Environmental, water quality, ionic concentration, medical, blood glucose and electrolyte analysis, industrial, process control and monitoring. Advantages of the potentiometric sensors: simple and low cost, low power consumption, high selective. Advantages of amperometric sensors: high sensitive, fast response time, capable of detecting very small concentration. At conclusion, To conclude, both potentiometric and amperometric sensors are powerful tools in modern science and technology. Potentiometric sensors measures voltage to find ion concentration, while amperometric sensors measure current from chemical reactions. They are widely used in environmental, industrial, and medical applications. Summary: both sensors convert chemical signals to electrical ones. Potentiometric measures voltage, amperometric measures current, widely used for safe, accurate, and quick measurements. Thank you for listening.